Okay, we're talking about comparing strings. So let's just do an example here. So I'm going to say, oops, I'm going to say system, yikes, I have to spell it right. System out, print, enter your name. And then I'm going to do string first name is equal to keyboard next line. And then we're going to check to see what it is. So if first name is equal to Bob, then I want to say, yep, it is. System.out, println, yep, it's Bob. Otherwise, I want to say, nope, it ain't Bob. Okay, so let's try this to see if it works. All right, here we go. So my age, I'm going to use my magic number 42. Enter my name, B-O-B, just like it is in the thing. And it says, nope, it ain't Bob. What happened? That's not exactly how string comparisons work, because strings are not native things. They're not that low level kind of a thing. They're class objects. So when you do a comparison of a class object, what you're actually comparing is the location in memory where those things exist, which is not at all what we had in mind. So what we have to do is we have to do something slightly different. Instead of doing it this way, in fact, hey, this would be a good opportunity to comment that line out. I'm just going to do that, doink. And then we're going to do one like this. It says first name dot equals Bob. Okay, so when you're dealing with strings, you have to use the methods to be able to do comparison. All right, so let's just try this one more time. Okay, my age is 42 and my name is Bob. And this time, yes, it's Bob. Okay, so just remember that when it comes to comparing strings, you just can't use those relational / comparison operators like you did before. So here's the ones that I use. By the way, there was a gazillion of these things, right? If I go down to here and say, first name dot, and there, boom, bunch of these things. So one of the ones that I use equals. And there's another one called compare to. And compare to is kind of sort of like equals, but it tells me if it's above it in sort order, below it in sort order, or exactly that thing. So it returns a number. It returns a -1 if the word is below it in the sort order, a +1 if it's above it in sort order, and a 0 if it's actually the exact same word. So that's the compare to. So is this case sensitive? What do you think? Yeah, it's case sensitive. So let's try this again. So my age is 42 and my name is B-O-B with capitals. And it's going to come back and say, no, man, that ain't Bob. So how do you fix that? Well, there's another one. There's one that says dot equals ignore case. So when I first typed this, if I had said first name dot and start with the letter E equals ignore case. Ooh, that would be getting me exactly what I had in mind. Okay, so on page 147, they talk about variable, declaration, and scope one more time. Now this is kind of sort of a repeat, but that's okay. So let's talk about it. When you create a variable inside a block, and a block basically is determined by curly braces. Now, it's also determined by indentation level, so I often say indentation, but technically it's by the block, which is the curly brace. It's just in our world, the curly braces are indented. Okay, so kind of sort of the same thing. Okay, so the variable scope is determined about where that variable is declared. For example, I created this thing called string first class, first name, right here on line 92. It's only visible inside this indentation level, inside this scope. Okay, but it is available in a deeper. In other words, every block inherits the scope of the block above it. Ooh, okay, isn't that kind of good? So the inner block inherits the scope of the outer block. So yes, first name is visible inside this block on line 97. Cool? All right. Now, if I was to create a variable here, okay, let's do one. String last name equals Jones. Okay. And then, oh, doggone it. And then let's go down here and say, so what's the last name? System.out print ln last name. It's going to say, what? Huh? Can't find that symbol. Well, there it is right there. How come you can't find it? Oh. Ha ha ha. Well, let's help out. Okay. Now that I spelled it correctly, let's go back to the error message. It says can't find the symbol. But there it is, last name and last name. So why isn't that working? Because the inheritance only goes in one direction. This outer block that's on this indentation level here is not inheriting from the inner. Okay, kind of makes sense? Good. I'm going to have to comment this out. Otherwise, it's not going to make any sense. Okay, good. Okay, on page 149, they talk about another operator. This is called a conditional operator, and that's a really strange name. Okay, conditional? That doesn't mean anything at all to me. Anyway, it's one of the few operators that takes three parts. You know, like the plus operator and you know, takes two parts, right? You know, left-hand part and the right-hand part, right? Kind of makes sense. So most of the operators, take two parts. But this is one that takes three. And so here's it's just a shortcut. So on page 149, they show an example of this, where here's an example of where you would do it. You'd say, if x is less than y, then y is equal to 10, otherwise y is equal to 20. And you could put that all on one line like this using the question mark and colon operators, okay? So it's just a shortcut. It's, you know, you could type all this stuff out. Now, let me tell you where I use this. I use this inside print lines, okay? That's where I use this. So for example, here's a classic example of, I'm not going to try to make this too complicated, but I have a countdown timer, and it says, you know, you have a spot, and it says so many minutes to go. So 2 minutes to go, and then it comes down and it says 1 minutes, plural, to go, and you go, well, that's not good English. So the position of the S, whether or not the S shows up in the word minutes, I do it with this. I basically say if, you know, whatever it is, the thing that, you know, countdown timer, you know, equals 1 or greater than 1, then put in an S. Otherwise, you don't put in an S. So anyway, that's the technique that I use, but I only use it kind of rarely, and it's pretty cool. Okay. The next thing we're going to learn is the switch statement on page 150, and this is kind of sort of similar, to a nested if, or that if else if guy, except he's a lot different with regard to, you don't have to pay attention to what order you're putting things in, okay? You can just dump stuff into it. So let's do a demo, and there's one on page 151 that basically looks like this, where I have a switch and then some sort of an expression, and all of these expressions inside these things resolve to typically it resolved to a true-false kind of a thing if it was an if. But here, the expression resolves to one of these values. So there's a bunch of keywords here. There's switch, there's case, there's break, there's default. Okay. So let's just do a demo. So let's say, for example, I've got, I don't know, I can't think of anything right off the top of my head. So a robot command. So I'm going to do int robot command is equal to 40. And then I want my robot to do something based upon what command you gave it. So I'm going to say switch robot command. I always put it in curly braces. So here are the possible robot commands. So I'm going to say case 10 with a colon. And that one is going to make the robot go forward. Okay, so, system out, print ln, go forward. And then I'm going to put a break statement here. And then go to the next case. So case 20 is making the robot turn to the left as an example. Okay, and I'm not going to do all of these because, And so I'm going to put a break in here. And then I'm going to put what's called the default one. And default is going to be none of the above, okay? Which means you've issued an incorrect command. So I'm going to do system.out.println invalid command. Okay. Okay, so that is what this thing looks like. Now you can imagine that there could be lots and lots of these things, and they don't have to be in numerical order or anything. Okay, now notice the break statement. The break statement is there to make sure that this doesn't fall through to this guy. In other words, you don't want to go forward and turn left at the same time. So break is what terminates this thing. Now, up to now, we've been using blocks, and a block is defined by the curly braces, right? So curly braces were defining the stuff we want to do. Well, inside a switch statement, we don't use curly braces. Actually, you could use curly braces. You could actually put curly braces right here if you wanted to, but that's just not normal. So instead of using curly braces, we have to use the break statement instead. Okay, so let's go over some of the rules. Ooh, I like rules. Rules are things that show up on quizzes, so you might want to pay attention. Okay, the expression, the thing up here that gets evaluated, has to be a whole number, okay? It cannot be 12.4, or it could be a string, and that's it. So counting numbers, now it could be a byte or a short or a long or an integer, but typically it's going to be an integer. Integers and string, that's essentially it. The case statement is required. These things, the actual cases themselves, have to be constants or literals. Okay, you can't have a variable here. You can't go in here and say, age, right? So this thing has to be either a constant or a literal. The default guy is actually optional. You don't have to have one, but it's kind of cool. And then the break, although technically is not required, I'm going to make it required for this course. So yes, you're going to have to put break statements in every single one of these guys. That's to avoid a fall through thing. And if you have 2 or 3 things that you want to happen at the same time, like multiple one of these guys, then I could say something like case 30 and then just type case 40 like that. And then you type in whatever else you wanted. Okay, we're coming up on the 15-minute mark. Let's stop this and we'll pick up where we left off.